Section 3.6, Perpendiculars and Distance. The objective of this lesson is to find the distance between a point and a line, and to find the distance between parallel lines. Let's get started. The first concept to discuss is the distance between a point and a line. Looking at this diagram, if we have point C here and line AB here, we can find the distance from point C to line AB. There are several paths that we can take to get from the point to the line. We have this segment, this segment, this segment, an infinite number of segments to get from point C to line AB. And they can all be different lengths. So to determine the distance between that point and that line, we have to use one specific path. It is the shortest length from the point to the line. And that is always the length of the segment that's perpendicular to the line from that point. So the length of this purple line would be the distance from point C to line AB, because it is the perpendicular distance. Next, we're going to look at the distance between parallel lines. Although they're not shown in this diagram, parallel lines have these parallel markings, these little arrows to indicate that the lines are parallel to each other. And if we want to find the distance between parallel lines, we're going to use the perpendicular distance, just like we did in the previous case. The distance between these two parallel lines would be the length of the perpendicular segment from any point to the other line. So the length of this segment would give me the distance between the two parallel lines. We do have one theorem, Theorem 3.9. It is the two lines equidistant from a third theorem. It states that in a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. This term equidistant may be new, but it's just referring to the distance these lines are from the same line. These distances are equal. So here in the diagram we have line L and line J and line H in between them. This theorem says that if the distance between lines L and H is equal to the distance between lines J and H, so if the length of these two segments are equal, meaning they are equidistant from line H, then line L and line J must be parallel to each other. In this example, we're going to find the distance between parallel lines L and M with the equations y equals 2x plus 1 and y equals 2x minus 3, respectively. This tells me that line L is here, and this equation represents line M. Okay, so if we're going to find the distance between two parallel lines, we're going to have to use a perpendicular segment between the two lines and find the length of that segment. First thing we're going to do is graph the two lines. If you look at line L, it's written in slope-intercept form, so I can see that the y-intercept is 1. You know it crosses the y-axis at 1. And the slope is 2. Remember, slope is a ratio. So that would be a rise of 2 and a run of 1. So from my y-intercept, I go up 2 over 1. 2 over 1. When I draw a line through those points, I get line L. And for the other line, I'll do the same thing. I have a y-intercept of negative 3. So I'll plot that point first on my graph. And then I use my slope, which is 2 over 1. Remember, parallel lines have the same slope. And once I get a few points, I can draw my line. Okay, and here I have line M. Next, I want to draw the segment between the two lines so that I can find the length of that segment, therefore finding the distance between the lines. I can't use just any segment. I can't use this segment because it's not the perpendicular segment between the lines. I can't use this one. It's also not the perpendicular segment between those lines. So I have to find a segment that is perpendicular to both. I know how to find the slope of that segment. I know it's going to be the opposite reciprocal of the slope of these two lines, because that would make it perpendicular. I know if the slope of these two parallel lines is 2, then the slope of the segment that's perpendicular to it will have to be negative 1/2, because perpendicular lines have opposite reciprocal slopes. So now I just need to find a spot, a point, to start to draw that perpendicular segment. And I'm going to pick an easy point to work with, which is the y-intercept of one of the lines. And I'll just use line L. So from line L at the y-intercept, using this perpendicular slope, down 1 over 2, down 1 over 2, I can plot the points that are on that perpendicular line. Okay, so now I have my perpendicular line drawn. Ultimately I'm trying to find the distance between these 2 points here. So I can find the length of the segment between these 2 points here. And that will be the distance between my 2 lines. But I need to show that algebraically. First I'm going to call this line P. And I can write the equation of that line. Because I know the y-intercept is 0, 1, and the slope is negative 1/2. I can use the slope-intercept form to write the equation of that perpendicular line. That would be y equals negative 1/2 x plus 1. Now I can use this equation to help me find this exact point where line P intersects line M. To find the intersection of line P and line M, so to find that point that line P intersects with line M, I'm going to have to solve a system of equations. It's not something I can easily determine by looking at the graph. And I have my 2 equations that are my system. You may remember that to solve a system of equations, we could use a few different ways. I'm going to use the substitution method to solve the system. I have both of these equations already solved for y. So I'm just going to take one of them and substitute it in for y in the other. So I end up with negative 1/2 x plus 1 equals 2x minus 3. Now I have an equation with just x, and I can solve for x. Okay, I'm going to subtract 2x from both sides. I get negative 2.5x plus 1 equals negative 3. And then I'll subtract 1 from both sides. Lastly, I'll divide by negative 2.5. And I find that x is equal to 1.6. What that tells me is that this point of intersection, the x-coordinate is 1.6. To find the y-coordinate, we take this x value and we substitute it back into one of our original equations. So using the original equation, y equals 2x minus 3, I can take that x value and substitute it in for x. Y equals 2 times 1.6 minus 3. And simplify, y equals 0.2. So all of this was used to find the intersection of line P and line M. And that point is 1.6 0.2. Now I have 2 points, one on line M, one on line L, and they are both on the perpendicular line that intersects both parallel lines. And now I can find the distance between those 2 points. Remember, if we have 2 points, then we can use the distance formula to find the distance between the two. Here I have our 2 points. I'm going to write them again right here. 1.6 and 0.2. Here's the distance formula to use. Remember, x1 and y1s, x2 and y2s come from the 2 coordinate pairs, or the 2 points. So I'll call this one x1, y1, and x2, y2. I'm going to substitute into my formula. Okay, when I simplify all of this under the radical, I end up with, okay, I get 2.56 plus 0.64, which is the square root of 3.2, and that's approximately 1.8. So the distance between the two parallel lines, L and M, is about 1.8 units. So let's just recap real quick what we did. We were given 2 parallel lines. We knew they were parallel because they had the same slope. And we graphed them. We wanted to find the distance between them. So we know that takes a perpendicular distance. So I picked a point, I picked an easy point, like the y-intercept of one of the lines. And using the perpendicular slope, graphed the line P that intersected both of those parallel lines. I used the system of equations, which is the equation for line P and the equation for line M, to see where those intersect. And then I used the original y-intercept and that intersection point that I found and the distance formula to find the length of that segment, or the distance between the two lines. We have some practice problems for you to do. First and second period, you guys are going to do this particular problem. Don't worry about the other two. Third and fourth, you will use this one. And fifth and sixth, you will use this one. Make sure you bring these back to class with you. And we can go over any questions that you may have at that time. Make sure that you spend some time and try to solve this problem. Your effort will be graded. Just use the steps that were shown in example 1 to work through this one.